This is Isaac Physics question D7.1. Just take a second to pause the video and read through the information in the question. Okay, so we have to work out the photon energy in electron volts. We've been given the frequency of the light, and that is it. So to calculate the energy of a photon, we use this equation, E equals hf. We know the frequency, we know h is just a constant, and we can work out E. So we're going to sub in our values for h, 6.63 times 10 to the minus 34. And our value for f times 6 times 10 to the 14. And that gives us our value for E as 3.978 times 10 to the power of minus 19 joules. This is in joules, but the question wants us to give the answer in electron volts, so we're going to have to convert. How do we do that? Well, to convert from joules into electron volts, we need to divide by 1.6 times 10 to the power of minus 19. Electron volts is much smaller than joules, so we're going to divide by the conversion factor. So to get our energy in joules, we are going to do 3.978 times 10 to the power of minus 19 over 1.6 times 10 to the power of minus 19, and that will give us 2.48, or roughly about 2.5 electron volts. This is part B, this is D7.2. Just pause the video, take a second to read the question. So this time we know the photon energy, but we don't know the wavelength. So we are going to go from energy to wavelength. The energy is given to us in electron volts, so we need to first of all convert them to joules. So we're going to do the energy, which is 1.5 electron volts, convert that into joules. This time we're going to times it by 1.6 10 to the minus 19. So we'll do 1.5 times that conversion factor. And that gives us 2.4 times 10 to the power of minus 19 joules. Now that we've got energy, we can work out the wavelength. We're going to use the E equals hf equation. And considering we know the wave equation is the wave speed times wavelength times frequency, you can rearrange that and get f equals c over wavelength. And if I plug that in there for f, I get the energy of the photon is equal to hc over lambda. So these are two different forms of the equation. This is the one if you have frequency or you want to work out frequency. This is the one with wavelength instead of frequency in it. We want to work out wavelength, so let's rearrange this one to get it as wavelength equals. And we end up getting lambda equals hc over e. We're then going to plug in our values for hc and e, and we should get 6.63 times 10 to the minus 34. Not very tidy. Times the speed of light, 3 times 10 to the 8, because that's our wave speed in this case, divided by the energy, which we calculated to be 2.4 times 10 to the minus 19 joules. And we get a wavelength of 8.3 times 10 to the minus 7 meters. Our answer is in meters, but we have to give our answer in nanometers, so we're going to have to convert. We will be going from meters into nanometers. So that means we will be dividing by 10 to the minus 9. Nano meaning 10 to the minus 9, and because we're going from bigger to smaller, we're dividing by. That will give us 8.3 times 10 to the minus 7, which was our wavelength in meters, divided by our conversion factor, 10 to the minus 9, and we end up getting 830 nanometers. And that should be your answer.